Hello friends, today we are going to discuss example number 2. State whether the following statements are true or false and justify your answers. So we have to state whether the given statements are true or false, and you have to also give a justification for that. So the first statement is all equilateral triangles are isosceles. Second statement is some isosceles triangles are equilateral. Third, we have all isosceles triangles are equilateral. Fourth, we have some rational numbers are integers. Next, we have some rational numbers are not integers. Then we have not all integers are rational. And lastly, we have between any two rational numbers, there is no rational number. So, first of all, it was mentioned in the question about isosceles triangles. So, I'll just tell you what isosceles triangles are so that you can do this question, and even if you remember, just listen. So, isosceles triangles are those triangles which have two sides equal, and that's the basic definition for isosceles triangle. So now we are going to take a look at the solution. Solution first part, this statement is true because equilateral triangles have equal sides and therefore are isosceles. Since equilateral triangles have equal sides, all the three sides are equal, hence they'll also be isosceles because isosceles require only two sides to be equal. So this was the first part. In the second part, we have this statement is true because those isosceles triangles whose base angles are 60 degree are equilateral. So an isosceles triangle, when you draw it with a base angle of 60 degree, two angles are going to be 60 because two sides are equal, and then from that you can understand that the third angle is also going to be 60 degree and the triangle is going to become an equilateral one. So this is the second part. Try to draw it also, it's going to be helpful for you, but that is the basic outlay of this particular part. Moving on, we have the third part. This statement is false. Not all isosceles triangles will be equilateral. So it is not necessary that all isosceles triangles are going to be equilateral, because isosceles triangles need to have two sides equal, whether equilateral triangles should have all the three sides equal, and it might happen that this is not going to hold true. It's not going to hold true because isosceles will have only two sides equal, but for equilateral all three sides need to be equal. So you need to think about it a little. Next, we have this statement is true since rational numbers of the form p by q, where p is an integer and q is equal to 1, are integers. So for example, we have 3, which is 3 by 1. So the statement for this part was that some rational numbers are integers, and basically integers we know that are of this particular form, like 3, minus 3, 4, and you can write them in p by q form, and hence this statement is true. So moving on to the next part, we have this statement is true because rational numbers of the form p by q, where pq are integers and q does not divide p, are not integers. For example, 3 by 2. So the statement was that some rational numbers are not integers, and as you can see that if we take an example also here, which is 3 by 2, and when you divide 3 by 2, you'll get 1.5, which is definitely not an integer. So whenever you're not able to understand if a statement is going to be true or not, just try to take an example and then understand it. Next, we have this statement is the same as saying there is an integer which is not a rational number. This is false because all integers are rational numbers. So the statement for part number 6 was that not all integers are rational, but this is a false statement because rational numbers constitute of integers and all integers are rational numbers. So this is a very false statement, and this is like the basic understanding which we have built. And yes, so that's it for this particular part. So moving on, we have part number 7. This statement is false. As you know, between any two rational numbers, r and s, lies r plus s by 2, which is a rational number. So the statement for this part was that between any two rational numbers, there is no rational number. But we know that between two rational numbers, r and s, r plus s by 2 lies, and that is also a rational number, and hence the given statement was false. So this is how we have explained this particular question part by part, and I hope that you understood what I explained to you. So let's take a look at some tips now which are going to be very helpful for you in solving similar types of problems. So always read the question properly. So it is important that you read the question, because what happens a lot of times is that you mention that a given thing is true or false, but you don't justify. And if it is mentioned in the question to justify and give a reason for your answer, you have to do it. And the next tip which we have is that read the statements carefully and try to make out what the statement is trying to convey. So it is very important that you understand the statements and try to make out what it's trying to convey to you. And if you're not able to understand it, you can try taking an example and then understand it, because many a times taking an example helps you a lot. So this was it for today's video, and I hope that you had fun watching it. Thank you so much for watching.